In the last video, I explained how the substitution method works for solving a system of linear equations. In this video, we're just going to work through some more examples so you really get the hang of this. And we will see examples where these last two things happen. So you'll see what those look like. Okay, let's solve this system. 2x minus y equals 4 and 4x minus y equals 2. First thing I have to do is pick one or the other of these equations and solve it for one or the other of the variables. So I think I'm just going to start with the top equation and solve it for y. Get it so that y is by itself on one side. So to do that, first I will subtract 2x on both sides. So that would be negative y equals 4 minus 2x. And then I don't want negative y, I want y. So I'm going to divide both sides by negative 1. And I get y equals negative 4 plus positive 2x. Now I'm going to substitute that in place of the y in the second equation, the one I haven't done anything with yet. So when I do that, it's 4x minus the thing that y is equal to, negative 4 plus 2x equals 2. Notice I put that in parentheses because I want to make sure that this minus applies to the whole thing. I'm subtracting y, so I'm subtracting this whole thing that y is equal to. So I'm going to start by removing those parentheses and distributing the minus sign. 4x minus a negative would be plus positive 4, and then minus a positive would be minus 2x. So 4x plus 4 minus 2x equals 2. Now, combine like terms that are already on the same side. The 4x minus the 2x together makes 2x. So 2x plus 4 equals 2. Now, leave the x term where it is, but we want it to be by itself on one side. So subtract 4 on both sides. 2x equals, and then this 2 minus the 4 would be negative 2. And now go from 2x to just x by dividing both sides by 2, x equals negative 1. Remember, we're not done until we have two numbers, a number for x and a number for y. So now that we have the number for x, come back up here where we solve for y and put in negative 1 in place of that variable x. Y equals negative 4 plus 2 times negative 1. So that would be negative 4 plus negative 2, which is negative 6. And that's my solution. Negative 1 for x and negative 6 for y. This isn't the only way you could have done this. I could have started with the second equation and solved it for y and substituted that into the first equation and gone from there. And I could have solved one of these equations for x instead of y. Would have been a little more complicated because I have to divide through by something. There might be fractions involved, but I could do it that way. So if I gave this same set of two equations to a bunch of different people who all are good at algebra, they know how to do this, I bet you some of them would do it one way, some would do it another way, and if they didn't make any mistakes, they'd all get the same final answer. Next example. Here are the two equations that make up this system are y equals negative 3x and 6x plus 2y equals 10. Now the top equation is already solved for y. That makes our job easy. We don't have to manipulate it. We just have to take this and say, okay, if y is equal to negative 3x, we can take that negative 3x and say, okay, you go in place of y in that other equation. So when I do that, that other equation becomes 6x plus 2 times negative 3x equals 10. Now if I multiply that out, that would be 6x plus negative 6x equals 10. And when I add together 6x plus negative 6x, that adds up to 0x, or just 0. 0 times x would be 0. So I got 0 equals 10. That just plain old can't happen. 0 equals 10 is just plain not true. No matter what's going on for x, 0 can never equal 10. That equation has no way of being true. It is a contradiction, and that tells me that my system here has no solution. There's no way to get both of those equations to be true at the same time. No numbers I can put in for x and y, and they have to be the same numbers in both equations, that satisfy both of those equations at the same time. So this is an example of an inconsistent system. If we actually did draw the graphs of these two equations, they would be parallel lines. So there's no point that's on both lines. Okay, how about this example? Y equals 3x plus 5 and 12x minus 4y plus 20 equals 0. Again, one of these is already solved for y, so we're all ready to make our substitution. Okay, 3x plus 5, you go in for y. And when that happens, the second equation becomes 12x minus 4 times 3x plus 5 plus 20 equals 0. Now, multiply this out to get the parentheses out of the way, distribute the minus 4, and we get 12x minus 12x minus 20 plus 20 equals 0. Combine like terms over here. 12x minus 20 plus 20. That just all adds up to a big 0. So we have 0 on the left equal to 0 on the right. 0 equals 0. That's sort of like what happened in the last example, but with a big difference. 0 equals 0 is true. No matter what's going on with x, that's a true equation. That's an identity. So when that happens, that means that our system has infinitely many solutions. It's a dependent system. There's not just one way of making the two equations true at the same time. There's infinitely many ways of doing it. Now, that doesn't mean anything goes. That doesn't mean x and y both can be any numbers you want, but it does mean that if you find a pair of numbers that works in one equation, that same pair of numbers will also work in the other equation. So you have multiple possibilities. X could be 0 and y could be 5. The first equation would be true, and so would the second. X could be 1 and y could be 8. X could be 2 and y could be 11. X could be negative 1 and y could be positive 2. X could be 10 and y could be 35. So if you drew the graphs of these two equations, they would both turn out to be the same line. The graphs would just be right on top of one another. So any point along this line is going to have x and y coordinates that work in both equations. That's why there's infinitely many solutions to the system. Okay, one more example. Here the two equations that make up my system are 4x plus y equals negative 1 and negative 6x plus 5y equals negative 18. So I want to start by solving one or the other of these equations by one or the other of the variables, whichever's easiest. I know what I think is easiest. Do you agree? I think it's easiest to take the top equation and solve it for y, because the y already is just a coefficient of 1. So if I take that and I subtract 4x on both sides, I get y by itself equals negative 1 minus 4x. Okay, so now I'm all ready to make the substitution. Okay, negative 1 minus 4x, you go in for y in that second equation, the one we haven't touched yet. So when that happens, it turns into negative 6x plus 5 times negative 1 minus 4x equals negative 18. Okay, so now we got this equation that's all about x. just focus on this equation here, solving it to get x. So let me start by multiplying this out to get rid of the parentheses. Negative 6x minus 5 minus 20x equals negative 18. I can combine the two x terms that are on the left side. The negative 6x and the negative 20x together make negative 26x. So negative 26x minus 5 equals negative 18. I can add plus 5 to both sides to get rid of that minus 5, undo subtraction with addition. So negative 26x equals negative 13. And now to go from negative 26x to just plain x, divide both sides by negative 26. So x becomes negative 13 divided by negative 26, and a negative divided by a negative would be positive, and that comes out to be, well, it's not a whole number, it's a fraction, but in lowest terms, it would be 1 over 2, 1/2. If you did that on a calculator, it would give you it probably as 0.5 in decimal form. So you can write it either way. X is 1/2 or 0.5. And now we can take that number and put it in place of x here. Y equals negative 1 minus 4 times 1/2. Well, let's see, half of 4 would be 2. So negative 1 minus 2 would be negative 3. We have our solution. X is 1/2 or 0.5 and y is negative 3. And that does work in both equations. Both equations are going to be true if you plug in 1/2 for x and negative 3 for y. 4 times 1/2 would be 2, plus negative 3 is equal to negative 1. Negative 6 times 1/2 would be negative 3, plus 5 times negative 3 would be negative 15, and then that negative 3 plus that negative 15 equals negative 18. So that's it for the method of substitution.